Hey, sixth graders, today's lesson and tomorrow and the next days after that lesson is on the difference between metals, nonmetals, and metalloids. So these are three different types of elements that are on the periodic table. We're going to talk about the physical and chemical properties of all three and where they are found on the periodic table. First of all, before we get in that, I'm going to go ahead and show you how they're organized on the periodic table. So all of the ones right here in this silvery bluish color are metals. The ones in green are our nonmetals. And these goldish ones are the nonmetals. I said that wrong. These are metalloids. My bad. The green is the metalloids. And this color over here is the nonmetals. So how you can remember this is this B right here. Y'all already know what it stands for. That's boron. Well, here's a little rhyme to help you remember it. Boron the moron is the leader of the stupid stairs. So see this staircase going down? Stair starts with an S. Stupid starts with an S. Stupid stairs. If a person is a moron, they're considered stupid. So it helps you remember boron because it rhymes with moron, is the leader of the stupid stairs. So the staircase has the metalloids, and then you just have to know that these extra ones right underneath it are also part of the metalloids. How it kind of works with their physical and chemical properties is that the metalloids are in between the metals and the nonmetals. They have a little bit of metallic or metal properties, and they have some nonmetal properties. So how I think about that would be like the metals would be black and the nonmetals would be white, and gray is a little bit of both. Gray has a little bit of black qualities to it, and gray has a little bit of white qualities to it, and so it has both. So metalloids are the in-betweens, and they're a little bit like nonmetals and a little bit like metals. You'll notice that hydrogen over here is a nonmetal. Even though it's on this side, it is very much of a nonmetal. All right, so now let's talk about some of those properties. All right, our essential question today that we're going to be answering and tomorrow and the next day are what are metals, nonmetals, and metalloids, and how are physical properties used to compare metals, nonmetals, and metalloids? If you were quizzed today, what questions would you know the answers to already? Think about that in your head, and then think about what questions would you need to learn more about to be able to answer these questions. All right, so metals, nonmetals, and metalloids. Let's review what a physical property is. Physical properties can be observed or measured without changing the composition of the matter. We've been talking about physical properties since like third grade, so you should be pretty confident of what it is. You don't change it at all. That would be a physical change. You're simply using your senses to be able to identify something's physical properties. So this includes its appearance, how it looks, its texture, how it feels, its color, how it looks, odor, how it smells, its density, its luster, conductivity, malleability, ductility. These are all physical properties that we learned about before Thanksgiving, back in October. So a quick review of some unusual ones that were new vocab words for you. Luster refers to the way that a metal's surface reflects off of light. It's shiny, or if it's dull, so it has luster, does not have luster. Another one is ductile. It refers to the way that most metals can be stretched into wires. So this is copper, just straight copper that comes from the ground. It can be pulled and stretched into wires. The example that we looked at when we learned about ductility was Laffy Taffy. Remember that big Laffy Taffy machine and how it's pulled and stretched? This would also be that if you took Play-Doh and made it as a snake, and then you twirled it around and around and around, that would be pulling it and stretching it. If you rolled it, that would be malleability, which is our next one. Malleability refers to the way that most metals can be hammered or rolled into thin sheets. So if you can flatten it with a hammer or roll it into a thin sheet like aluminum foil, it has malleability. Brittle is the tendency of a material to fracture or fail with a small amount of force. So glass is very brittle. If you drop it, it's going to break into a whole lot of pieces. Examples are grass, silicon, chalk. This is sulfur. It's very brittle. It breaks into pieces easily. Are there examples on the others? No? Okay. All right. Conductivity, you've learned about this one since 4th grade. Measure of which the ease at which electrical charge or heat can pass through a material. So if electricity can go through it, it has conductivity. If heat can go through it, it has conductivity. An insulator is the opposite. It's a material that keeps energy, such as electricity, heat, or cold, from easily transferring through. So wood is an insulator. It doesn't allow heat to move through. It will eventually burn, but it's not good at letting heat move fast. So the plastic on here, the rubber on this, is an insulator. The inside right here is a conductor. It allows electricity to go through. The rubber is on the outside so that you can pick the wire up without getting electrocuted. So the electricity does not go through that rubber or plastic wire. All right, so I do not like this picture of the periodic table because it's got a lot going on. Every single different color combination that you see represents something. They're hard to look right here, but these are all of the different colors that have different things in common. So all of the pinks have something in common. This shade of greens have something in common. This shade of yellows, and so on. And then don't forget, you go sideways, all of these have something in common. All of these have something in common. What I wish we had here, and I tried to delete this periodic table, but I couldn't. I wish we just had, not that, this. This is what you need to know. This, you won't get this until chemistry, which you take as a freshman or sophomore or 9th or 10th grader. So just ignore all these different colors. This is what you have to know as a 6th grader. All right, so let's talk about metals. Metals, most of the elements are metals. 88 of the elements to the left of the stair step line, to the left of the stupid stairs, are metals or have metal-like elements. Most are liquid. Most are solid at room temperature. So that means if it's metal and it's just at regular temperature, it's not super, super cold or super, super hot, it's going to be a solid. One of the exceptions to that is mercury. Mercury is very much of a metal, but at room temperature, it is a liquid. It's a poisonous liquid, so you don't want to touch it when it's at room temperature because it can get into your skin. It would slowly poison you. All right, so some physical properties of metals. All metals have luster. They're shiny. All metals are good conductors of heat, electricity. You know that. Metals get hot. Electricity moves through metals. They're high density. That means they're heavy for their size. So this would be very dense. So this is super dense metals. This would be less dense of something. It wouldn't be very heavy for its size. Again, this one's not very heavy. Most dense. And then second most. They have a high melting point. That means they have to get super, super, super hot, like in the 200s, for them to be able to melt. I remember whenever my husband's aunt and uncle had their house burned down back when the big forest fire came through Bastrop and burned down a lot of homes in Bastrop. This would have been in the summer of 2011. So y'all wouldn't remember it. But anyways, their house burned down. And there was absolutely nothing left to their house but ashes. The only thing they could identify from their home was the metal barrels of their shotguns. Everything else was completely melted, including the gun case that it was in. But whatever metal is that was made out of those shotguns had a high melting point that even the temperature of that very high fire, it did not melt in that versus all the other metals in the house did. All right, ductile. Most metals can be drawn or pulled into thin wires. This would be ductile right there. Not all metals, but most. And then most are malleable. That means most metals can be hammered into thin sheets. All right, some uses of metals. Copper is used in electrical wiring. It's always used in coins. Gold is used in jewelry. It can also be used in teeth fillings in the teeth. Lithium is used in medicine and in batteries. All right, so here's our periodic table. Here is our stupid stairs. So everything on this side, except for hydrogen, is a metal. All of these are metals as well. And then over here is going to be our nonmetals. All right, so nonmetals are found to the right of the stair-step line. Their properties are the opposite of the metals, so it makes them easy. They're opposite. Most of them are gas at room temperature. So the ones that are yellow over here, blue, and purple. Here, this gray one are your metalloids. So everything on this side of your gray metalloids. All right, so some physical properties of nonmetals. They do not have luster, so we would call them dull. Okay, look at this. It's dull. It's not shiny. It's a poor conductor of heat or electricity, so that means it would be considered an insulator. This is an insulator right here, even though it's a metal. I don't know. Excuse me. It's a non-metal. This would be an insulator used on some electrical stuff. It's brittle. It breaks easy. So sulfur, it just breaks apart easily. Kind of like chalk, breaks easy. Peanut brittle, breaks easy. But this is not a non-metal. It's a food. Just an example. It's not ductile. You cannot pull it into wires. Non-malleable. You can't roll it into sheets. It's low density. This is low density. And it has a low melting point. An example of low melting point is M&Ms. If you put M&Ms in your hand, they're going to melt relatively easily. Non-metals are that way also. They become liquids quickly, which is why at room temperature, they're considered a gas, and so at room temperature it's extremely hot for them because it has to be very, very hot to be a gas. So they consider the temperature of 72 degrees in this classroom to be crazy hot, so that's why they're a gas. Versus metals would consider this crazy cold. That way it is, that's why they are solid. All right, some uses of nonmetals. Oxygen, it supports life. It's also used in rocket fuel. Chlorine is a nonmetal. It's used in water purification, like in a swimming pool. And it's used to make PVC pipes. That's the white pipes. Helium, y'all know that's some fun stuff, helium balloons. And it's also used as a coolant. All right. So now let's talk about metalloids. So boron, the moron, is the leader of the stupid stairs. It's the gray right here. They have elements on both sides of the zigzag line having properties of both metals and nonmetals. Boron, the moron, is at the top of the stupid stairs. So I like the fact that it's actually gray here. And the color coding, you can make these any colors you want. They just happen to make it gray. And that fits with my analogy of metalloids have a little bit of metal qualities and a little bit of non-metal qualities. Kind of like gray is a little bit of black in color and a little bit of white in color. All right, so some physical properties of metalloids. They're all solids at room temperature, every single one of them. So that's something they have in common with the metal. Metals are solids. However, they can be shiny or dull, shiny like a metal or dull like a non-metal. They can be either one. Some of them are shiny, some of them are dull, some of them are just kind of in between. They are ductile and malleable. That's something they have in common with metal. They can conduct heat and electricity better than nonmetals, but not as well as metals. So they're called semiconductors. They semi-conduct. They conduct a little bit, but not very well. So they can allow heat and electricity to go through them, but not super good. Versus a nonmetal, not at all. So they share properties with metals and nonmetals. They're a little bit of both. Some uses for metalloids. Boron, the moron, is heat-resistant alloys. It's the green color in fireworks. So boron is what makes green fireworks. Silicon is used in glass and semiconductors. Semiconductors are used in technology. And arsenic is a poison, extremely poisonous, and it also adds color to fireworks. Right, there's our periodic table. So here are metalloids, and our stupid stairs is our metalloids as well. Over here is our non-metals, and here is our metals. All right, and we're done. Now,